Hello, I'm Patty Simpson with Simpson Math. Let's solve equations with absolute value. First, let's talk about what it means to be the absolute value. Remember that the absolute value is the distance from zero. So in this particular equation, I'm asking, what number is 4 spots away from zero? Which number is the distance 4 units away from zero? Well, you may be thinking 4. Perfect. 1, 2, 3, 4. The number 4 is 4 spots away from zero. So 4 could be an answer for x. I could put 4 in here, and the distance from 4, the distance from 0 to 4 is 4. But there's another number as well that x could be, because there's another number that's 4 units away from 0. If we go to the left 4 units, 1, 2, 3, 4, that's also 4 units away from 0. So x could also be a negative 4, because negative 4 is also 4 spots away from 0. So the absolute value of negative 4 is also equal to 4. The absolute value is just the distance from 0. Or another fancy algebraic definition for the absolute value is that it's equal to a negative x if your x is less than 0. So in this case, when my x was negative 4, it's equal to a negative of that, because x is less than 0, it's equal to a negative of a negative 4, which makes it a positive 4. Or it's just equal to x if x is greater than or equal to 0. So in this case, it was greater than or equal to 0, so the absolute value of 4 was just equal to the 4. So when I have absolute value signs, that distance from 0, we could have a positive and a negative value for our x. That's going to be that far away from 0. So we have to keep this in mind when we're solving equations such as this, where I have 7x minus 3 is equal to 11. Because the number that's represented in here could be 11, so this thing may need to equal 11. 7x minus 3 could be 11 spots to the right, but this in here could also be equal to a negative 11. Both of those would make this true, because if it ends up with a negative 11 in here, the absolute value of negative 11 is still 11. If it ends up with 11 inside, the absolute value of 11 is 11. So we need to solve both of these equations in order to find the two answers that x could be. So remember, when solving the equation, we say what's not touching our x there, and we're going to get rid of or move this negative 3 first by zeroing him out. So the inverse of subtraction is addition, so I'm going to add 3 to both sides. And that leaves me with 7x plus 0, which is 7x. And then on the right, 11 plus 3, which is 14. I divide both sides by 7, because the inverse of multiplication is division. Divide both sides by 7, so that I have 1 times x, which is just x, and 14 divided by 7 is 2. Notice, if I put this 2 back in for x, 7 times 2 is 14. 14 minus 3 gives us 11. The absolute value of 11 is 11. That does make this equation true. But there's going to be another answer as well that x could be that would make this equation true. I'm going to go through these same steps where I add 3 to both sides. But notice this time when I add 3 to both sides, I end up with 7x on the left, just like I did before. But on the right, I have a negative 11 plus 3. I walked in the negative land, but then I turned back around. So I end up still in negative land, but I'm only 8 steps in, because 11 minus 3 is 8. Now I'm going to divide both sides by that 7, just as I did here, because the inverse of multiplication is division. And 1 times x is just x. And on the left, I have this negative 8 sevenths. So x could be equal to negative 8 sevenths as well, and it's going to make this equation true. I will show you. If I have 7 times this negative 8 sevenths, 7 divided by, remember the way you multiply fractions is you just multiply the top times the top, and the bottom, which is a 1, times the bottom. But this 7 divided by that 7 is going to be equal to 1. So I'm just left with negative 8 minus 3. Well, negative 8 minus 3 is equal to a negative 11. And the absolute value of negative 11, that distance from 0 is 11 spots. So that is equal to 11. So we could put 2 in there and it would make this equation true, or we could put in negative 8 sevenths to make this equation true. There are 2 things that x could be equal to. So whenever we're solving absolute value equations, we need to be sure and think about both that positive number value and the negative number value. So here's another example. We have 2x minus 2 equals negative 6 plus 15. So I'm going to simplify what's on the right first before I begin to solve this equation. So I'm going to simplify that on the right. I can't do anything on the left just yet. Those can't be combined. They're not like terms. But on the right, 15 minus 6 leaves me with a positive 9. Our absolute value should always equal a positive number because we're talking about that distance from 0. Or when we looked at that fancy definition, they both end up being positive. So this should be equal to a positive number. If it's equal to a negative number, then automatically we know that there is no x value that's going to make that true, because an absolute value should not be equal to a negative number. Now, to solve this, I know that the distance inside of here could be equal to 9. The number inside of here could be equal to 9. But whatever this is in here could also be equal to negative 9. Because negative 9, when I take the absolute value of it, is going to be 9 units away from 0. Now I solve the equations like I normally do. I add 2 to both sides so that I have 2x equals 11. And then I divide both sides by 2 so that x equals 11 halves. One answer that would make this true is 11 halves. I need to do the same thing with this equation. So I'm going to go through the same steps, but notice I'm not going to get the same answer. I'm going to get something different as I do it. Because here I do get the 2x, that zeroes out. But a negative 9 plus 2 is not equal to 11. Negative 9 plus 2, their signs are different, so I'm subtracting, and keeping that sign, I walked further into negative land. So we should end up with two different values there for x that it could be to make this equation true. So that x could be equal also to a negative 7/2. Let's see if we can do a couple more. Make them a little more challenging and see if we can solve those as well. But the big deal with absolute value is we're going to end up with two different answers for our x value when we solve these equations. So here I have the absolute value of negative 5x plus 6x plus 2, and that's equal to 3 plus 13. I'm going to simplify on the left and right first, just like I do when I solve all equations. So inside the absolute value, I can simplify here. I have 6x minus 5x, which just gives me 1x, plus 2. I'm going to find the absolute value of that x plus 2. And on the right, I have 3 plus 13, which equals 16. Once I've simplified, then I just have to remember that inside this absolute value could be equal to a positive 16. But it would also be true if this value in here was equal to negative 16, because the absolute value of negative 16 is still 16. So I need to set it up with two different equations. Now to isolate that x, I'm just going to subtract 2 from both sides, or you're asking yourself, what number plus 2 gives me 16? So 14 would work in here. 14 plus 2 gives me 16. The absolute value of 16 is 16. On this side, I subtract 2 from both sides, but here, negative 16 minus 2 gives me a negative 18. If I put negative 18 in here, negative 18 plus 2 gives me a negative 16. The absolute value of negative 16 is 16. So this x could be either one of those values, 14 or negative 18, and that would make that equation true. Let's do one more. We're going to find the absolute value of negative 3 plus 5 plus or minus 6x plus 3x. And that's going to be equal to 15 minus 11 plus 20 minus a negative 4. So first step is just to simplify on both sides of my equation. So inside my absolute value sign, I can simplify, I can combine these two like terms. So negative 3 plus 5 is a positive 2. And I can also combine these like terms, 6x, a negative 6x plus 3x is equal to a negative 3x. So negative 3x. Taking the absolute value of that. On the right, they're all just numbers, and I can combine all of those. So 15 minus 11 is 4. Remember, this negative times a negative is going to make that a positive. It's like there's a negative 1. Negative 1 times negative 4 makes that a positive 4. So absolute value of 2 minus 3x is equal to 24/28. Now that I've got I've got my absolute value is equal to a number, I need to make sure that it can be either equal to the positive version of that number, or it could be equal to the negative version of that number. And then I simply solve my equation. So I'm going to subtract 2 from both sides, which leaves me with a negative 3x equals 26. I'm going to subtract 2 from both sides, which leaves me with a negative 30. So notice that when I do this step, even though I'm doing the same thing on both of my equations, they're not necessarily the same, because here I'm subtracting from a positive and there I'm subtracting from a negative. So we're going to end up with 2 different answers here. Then I'm going to divide both sides by a negative 3. Divide both sides by a negative 3. So that x could equal a negative 26/3, or x could equal a positive 10. So both of those answers would make this equation true. So when we're dealing with absolute values, you just have to remember there's a positive value that could be inside the absolute value signs, or a negative value. So you need to come up with 2 solutions for your x's. Math Made Simple, it's Simpson Math. Thanks for watching.